Now you can simulate the performance or the characteristic of RTD by using a simulator. So click on to simulator, then you will go to simulator, and how to perform the experiment is you select the material, alpha is given to you, temperature range is given to you, then select RTD 0 resistance at 0 degrees Celsius, and then get the temperature. And once you put the value over here, if this is correct, you will receive correct, otherwise recalculate. Now this is an indication that the answer is incorrect. Go to formula, refer to the formula and solve the example again, then put the values. You will have to do it for 3 readings. Then the plot would be visible. So if you click on to the plot, it shows that the relation between temperature and resistance. So because this is a standard simulator, it will show you a straight line. Now you will find that the level 2 is now open, and level 2 means a dynamic characteristic of the RTD. So if you click on to bear, the time constant is 1.17 seconds. So if you just use only bare element like this, you will find that the time constant is 1.17 seconds, and the material used is platinum. But if you want to give a mechanical strain to that element, then you will have to add sheath, that means a cover on top of this RTD with a material, suppose SS304, you can add the material, you can add thickness to that material. The time constant will become 4.13 seconds. Now the question is, how do you validate these readings? So go to the formula. The details are given and the constants are also indicated. Use those constants and solve the equations. You will get these values. Similarly, if you still want to give better protection to that, use a thermowell. You can select material and you can select thickness, but on top of that you can select filling material also. In this case I am selecting MgO powder. The moment I have thermowell with MgO powder as filling material, thickness 1 millimeter, material SS304, the time constant will become 11.33 seconds. As compared to 1.37 seconds, it has gone to 11.33 seconds. So the system will become sluggish. And now you can plot the graph. So it will show you how the RTD will respond to a step change in the temperature. So in this case, this is with thermowell, which will be here around it will reach after 11 seconds. This is with sheath and this is bare element. So bare element reaches faster, then sheath, and then thermowell. Now this is how you can use these static and dynamic characteristics of RTD to identify a suitable sensor for your application.